Today we are going to study the new topic, that is the shadow zone. Now shadow zone is very much dependent on the earthquake. So first we'll review what is earthquake, how it has occurred, what are the seismic waves, what are the types of seismic waves. We will study the three types of waves, and totally on those types of waves the shadow zone concept is dependent. So let us study first what is earthquake. Now, earthquake refers to the shaking of a ground. Whenever the ground starts shaking, we say that the earthquake has been occurred. The movements occurring in the crust of the earth produce a lot of stress in the rock strata. So whenever a movement is occurred inside the crust, a lot of stress is created. Now this stress, when it gets accommodated beyond a limit, that time it has to be released. So when it gets released, it is released in the form of energy. Now these energy, when it is releasing, the waves are created, and those waves are called as seismic waves. When these waves they travel, it makes or it compels the earth crust to shake, and then the earthquake is being created or generated. The point where the accumulated stress gets released within the earth crust is called as seismic focus. In the figure you can see that inside the earth crust there is a point from where first the earthquake starts or the earthquake begins. That point is called as focus point or the seismic focus point. A point directly above it on the surface is called epicenter. In a straight line from the focus point, that point is called as the epicenter point, which I have labeled epicenter. The intensity of the shock is maximum at the epicenter and decreases with increasing distance from the epicenter in all the direction. So the epicenter, at the epicenter there is lot of destruction and the intensity is very much high as compared to the rest of the area or the surrounding area. The earthquake waves are recorded by an instrument called seismograph. So seismograph is used to measure or to record the intensity of the waves. Now in the figure you can see there are two types of waves they have shown. First is in a straight line and second is in an zigzag line. The straight line waves are called the primary waves and the zigzag line waves are called as the secondary waves. So these two waves play a major role inside your shadow zone concept. Okay, but the third type of wave is called as the longitudinal wave or love waves. So these waves they do not play any type of role in the case of shadow zone. Why? Because the shadow zone is created inside the earth crust and L waves they move on the surface area. They do not enter the mantle part, they do not enter the core part, or they do not come inside the earth's crust. The role of the L waves are limited only till the surface of the earth. Now let us understand the simple concept or the definition of shadow zone. Earthquake waves gets recorded in seismographs located at far off location. A seismic shadow zone is an area of the Earth's surface where seismographs can only barely detect any earthquake after its seismic waves has passed through the earthquake. So when the earthquake waves are generated, the seismograph can record the waves to a very far location also, but there is some location or there is some zone where the seismograph cannot detect any type of wave or any type of earthquake destruction. So that zone is called as shadow zone. There exists some specific area where the waves of the earthquake are not reported. Such a zone is called shadow zone. So whenever an earthquake is occurred, the area which is not affected or the area where the waves do not reach, that area which is preserved or which is protected from the earthquake, that area comes under the shadow zone. The study of different events reveal that for each earthquake there exists and altogether different shadow zone. So for every earthquake, there is different shadow zone. It differs if there is some different earthquake which has occurred at some other place, that earthquake will have some different shadow zone. The shadow zone is not same for all the earthquake. The shadow zone is the area of the earth from angular distance of 105 to 140 degrees from the given earthquake that does not receive any direct P waves. The shadow zone results from S waves being stopped entirely by the liquid core and P waves being refracted by the liquid core. So this is the zone where both the waves, that is S waves and P waves, means primary waves and secondary waves, they do not come under this particular zone. Which zone? It belongs from 105 to 140 degrees from where the earthquake has been occurred. Now we will study firstly what are the type of waves and its features. There are three types of waves: P wave, S wave and L wave. They are also called as primary waves, secondary waves and longitudinal waves. Let us study what is P wave. Primary waves are bundles of longitudinal waves that travel through both solid and fluid medium. So primary waves, they can easily travel or they can easily move from solid medium as well as from the liquid medium. Now next is secondary waves. Secondary waves are the bundle of transverse waves that can easily travel only through the solid medium. So the secondary waves, they travel only through the solid medium. The propagation of the resistance offered by the medium. Naturally, the resistance is more from solids. Of course, the resistance indeed affects the propagation of primary waves. L is also the first letter in love waves. When the amplitude of the motion is parallel to the surface, the wave is called as love wave. So whenever the wave it moves parallel on the surface of the earth, then we call it as the surface wave, love wave or longitudinal wave. These waves are propagated through the medium of solid, liquid and as well as gas. So it can move or it can propagate in all the three mediums. So there is the velocity in this propagation. If the propagation is like or unlike in the direction of velocity, the waves are called longitudinal. Otherwise, they are called as transversional waves. Now P waves, the shadow zone is the area of earth from angular distance of 104 to 140 degrees from the given earthquake that does not receive any direct P wave. So what is shadow zone? A shadow zone is an area from the point of earthquake, the angular distance should be between 104 to 140 where they do not receive S wave as well as they do not receive any direct P wave. The shadow zone results from S wave being stopped entirely by the liquid core and P waves being bent or refracted by the liquid core. Now as S waves, they cannot travel through liquid, they can only propagate through solid medium. So there is no question of S waves entering the shadow zone. And the P waves, it can travel through solid as well as liquid, but it gets refracted in the liquid medium. P wave, it can easily move in the solid medium, but when it enters the liquid, it gets refracted. So because of this, the shadow zone doesn't receive the direct P waves. The shadow zone is the area of the earth from angular distance of 104 to 140 degrees from the given earthquake that does not receive any direct P waves. And the shadow zone results from S waves being stopped entirely by liquid core and P waves being bent refracted by the liquid core. So the same two points are being discussed repeatedly, so because they are very important as per to your concept of shadow zone. Now let us study S waves. A seismic wave or the seismic shadow zone is an area of the Earth's surface where seismograph cannot detect any earthquake after its seismic waves have passed through the Earth. So the area which do not detect any type of seismic wave comes under the shadow zone. All are shear waves that travel in all direction away from the epicenter. So whenever the earthquake occurs, the from that point itself, all the waves they start traveling away, far away, and they reach to the maximum distance they can. The different phases show how the initial S wave is stopped or changes when encountering the boundaries of the earth. There are three common variations of S wave seismic body waves. All are shear waves that travel in all direction away from the epicenter of an earthquake. So, S waves are the waves which travel in all direction from the epicenter to the long distance. So the key points to remember in the case of S wave is seismic shadows are a global effect of seismic waves from large earthquake. S waves radiate spherically away from an earthquake in all directions. S waves don't appear beyond an angular distance of 103. S waves are stopped by the liquid outer core. So now S waves are generally created because of the seismic waves. Okay, S waves are the secondary waves. They move spherically in a circular way and they are radiated away in all the direction. And they cannot cross the angular distance of 103 degree. Why? Because that distance is covered by the liquid core of mantle. The outer core of the mantle is basically liquid and S waves cannot travel from the liquid medium. Hence, they are stopped in the liquid core itself. Because of that, they cannot enter the shadow zone. The shadow zone usually starts from 104 to 140. Because of that, the S waves are absent in the shadow zone. Next, why do earthquakes develop a shadow zone? The earthquake waves develop a shadow zone because the P and S waves follow a curved path in the interior of the earth, which proves that the density increases inside the earth. On reaching the core, S wave disappears and P waves are refracted and there is no wave for a distance. So, because of or with the help of P and S, the shadow zone is created. Why? Because of this, we can understand that the S waves they cannot move in the liquid medium and P waves they can move in the liquid medium but these waves they get refracted and hence there is absence of P and S waves inside the earth crust. What do shadow zone tells us? The shadow zone tells us how how is the waves or what are the things or how is the seismic waves working inside the earth. This shows how P waves travel through solid and liquid but S waves cannot travel in the liquid. So these things also we can understand because of shadow zone. The wave properties of light are used as an analogy to understand the seismic behavior. So, the properties of light is used to understand or the behavior of seismic waves. Why do shadow zone exist? Now what is the reason of the existence of shadow zone? The shadow zone is the area from the angular distance of 105 to 140 degree from the point of the earthquake. Now, this point does not receive any direct P waves as well as it does not receive any type of S waves also. Why S waves cannot come? Because they cannot move from the liquid medium. And why P waves cannot come? Because they get refracted in the liquid medium. So because of this, this zone is created, as both the waves cannot go in this particular area. Hence that zone is called as shadow zone, where not a single wave can propagate. Now what is shadow zone or how it is formed? You can see in the figure itself you have different layers, upper mantle, lower mantle. So these are different layers which are inside your earth crust. Now one is the solid layer and one is the liquid layer. Now wherever there is the solid layer, in that you can see all the waves, that is P as well as S, all the waves can propagate. But wherever there is a liquid medium, in that you can see that only S waves, they cannot come. Otherwise P waves, they can come but they get refracted. The waves which is caused by the earthquake is called as seismic waves. P and S waves and longitudinal waves are the three types of waves. P waves, it passes through all the medium. S waves passes only through solid medium. Even though P waves passes through all the mediums, they get refracted as they pass from one medium to another. So whenever there is the change of medium, means solid, liquid or gaseous, all these three mediums, whenever the wave passes and changes its medium, the direction of the flow of the wave also changes. A shadow zone is the area of the earth from 105 to 140 where the earthquake waves are not received. There is absence of seismic waves. This shadow zone results the stopping of P waves as well as the stopping of S waves because of their different reasons. A seismic shadow zone is an area of Earth's surface where seismograph can only barely detect any earthquake after its seismic waves have passed. When an earthquake occurs, seismic waves radiate out spherically from the earthquake's focus. So whenever an earthquake is created, the seismic waves, it moves in all directions from the focus. Now the concept of shadow zone, just we will overview all the concept. In the figure you can see the point is the from where the earthquake or the focus point, straight to the focus is the epicenter point. From there the earthquake seismic waves starts. Now there are two waves, P as well as S. P is denoted with yellow line and S is denoted with black line. Now in the initial you can see that both the waves, they are traveling as it is a solid medium. Okay. After coming to 105, what happens? There is a liquid outer core and then inside there is solid inner core. Now this liquid outer core, it does not allow the S waves to enter because S waves cannot travel from the liquid medium. Hence the S waves are stopped outside the liquid core itself. Now the P waves, they are entering, they have crossed the liquid medium, but the direction of the P wave has been changed. They are being refracted. So because of that, even the P wave, they enter to some medium to some zone, and then they cannot enter in some zone. Now in the zone where the P wave cannot come directly, that zone is called as the shadow zone. Hence the shadow zone is created from 105 to 140, as well as the shadow zone is created where the P waves cannot come directly. Now let us go through the concept. Wherever the earthquake is not reported, or the area where the earthquake or the seismic waves are not reported, that area is called as shadow zone. Now the shadow zone is totally dependent on the concept of P and S waves. We have already studied that P waves can travel in all mediums, but S waves cannot travel through liquid medium. It can only travel in solid medium. Seismograph located at the distance within 105 from the epicenter has the existence of both P and S. In the figure you can see from epicenter to 105 you can see the existence of both P as well as S waves. The seismographs located beyond 140 from the epicenter record of P waves but not of S waves. Now in the figure beyond in front of 140 beyond 140 you can see only P waves are seen, S waves are totally absent. Zone between 105 to 140 from the epicenter is called as shadow zone for both the types of waves. So from 105 to 140 you can see that it is a shadow zone where both the waves are not present. The entire zone beyond 105 does not receive S waves. So once the liquid core starts, the S waves cannot enter, and because of that from 105 the whole entire zone does not receive the S waves anymore. The shadow zone of S waves is much larger than that of P waves, as the P waves they propagate from the liquid core, from the solid core. Because of that, the shadow zone of P wave is very much less as compared to the shadow zone of S waves. Why? Because S waves are stopped at the initial point itself. The shadow zone of P waves appears as a band around the Earth between 105 to 140 away from the epicenter. The shadow zone of S wave is larger in extent. You can draw the shadow zone for any earthquake provided to you by knowing the location of the epicenter. So after knowing the epicenter, using these guidelines and using the working and the concept of P and S waves, you can draw the shadow zone for any type of earthquake in future. Thank you for watching.